Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signal and System Analysis. In this video, I will show you the solution to sample problem on how to find total response of a linear differential system. Okay, so the question is given here where you are asked to determine the total response for the system described by the following differential equation when it is subjected to an external input of x of t equals to ut and initial condition of y0 equals to 3 and y dot 0 equals to 1. So this is the differential equation that describe the system. Okay, so here you are given the steps that you have to do in order to determine the total response of the system. So first you have to find the zero input response of the system. Second, you have to find the impulse response of the system. The third step is to find the zero state response of the system, and finally you can find the total response of the system, which is equivalent to the zero input response plus the zero state response of the system. Okay, so let's do this one by one. So first we have to determine the zero input response of the system. Okay, and the first step to do that is to determine what is the characteristic equation of the system, okay, which is q lambda equals to 0, and what are the characteristic roots of the system. Okay, so if we write this differential equation in terms of the D operator, we will have, okay, where the capital D equals to d over dt. Okay, so we will have 2d plus 3 y of t equals to 5x of t. Okay, so the characteristic equation, okay, this one is simply q of d, the whole polynomial, okay, and this one is p of d. Okay, so the characteristic equation here, okay, is simply obtained by substituting the d in this with lambda. So we will have the characteristic equation 2 lambda plus 3 equals to 0. Okay, so if I find the root of this equation, I will have lambda equals to minus 3 over 2, okay, which is to be expected. We will have only one lambda because here we have a first order system, okay, so there will be only one root. Now since we have only one lambda, so the general equation of the system, okay, the general solution of the zero input response will be CE lambda t. Okay, so if I to substitute lambda, I will have CE minus 3 over 2 t. Okay, so the next step is to determine C. Okay, since we only have this is the first order system, so we only have one unknown C, so we need only one initial condition. So let's say y0 of 0, which is equals to 3, equals to CE. Simply substitute this t with 0, so you will have e to the power of 0, so 3 equals to C. So now the characteristic equation will the solution will be y0 of t 3 e minus 3 over 2t, okay, which is our zero state response, zero input response. Okay, y0 of t equals to 3e minus 3 over 2t. Okay, so this is the zero input response. Okay, Next step is to find the impulse response. Okay, so the first step to do that is to determine what is BO and PD. So let me just write back the polynomial in terms of the D operator. Okay, so it will be 2D plus 3 y of t equals to 5 x of t. Okay. And then we want to find BO. So if we look at the equation here, okay, this D here is to the power of 1, okay, which is to the power of n. Okay, so n equals to 1. And here we don't have D. Okay, so which means in this case we have D to the power of 0, means there's no D. Okay, so m equals to 0. Now since we have m smaller than n, okay, so BO equals to 0. Now PD is simply this polynomial here. Okay, PD. So PD equals to 5. Next step is to determine lambda and c, okay, in order to determine yn of t. Now this lambda is similar, okay, will be minus 3 over 2, will be the same lambda as we get here, okay, because we will have the same characteristic equation, 2 lambda plus 3. Okay, so that means we have the general solution of the yn of t equals to CE minus 3 over 2t. Okay. However, this C here, okay, will not be the same as the C we obtained in the previous step, because the initial condition, okay, for impulse response is different from the initial condition that is used to find the zero input response. Okay, so for the impulse response, okay, this one is available in the slide and also in the video where I discuss impulse response. Okay, since we have n equals to 1, okay, so your initial condition will be 1, okay, y(o) of 0 will be 1. So this is the initial condition that is used to determine impulse response, which is different from before, because before we have y(o) of 0 equals to 3. Okay, so if we substitute this into the equation, y(o) of 0, which is equals to 1, equals to c e to the power of 0, so c equals to 1. Right, so we have yn of t equals to e minus 3 over 2t. Now we have to find h of t, which is given by this equation over here. Okay, and we know from the previous step that BO equals to 0. Okay, so we are left with h of t equals to, and PD is equals to 5. Okay, we already determined here. So this one is 5 multiply with e minus 3 over 2t u of t. Okay, so the impulse response is equals to 5e minus 3 over 2t ut. Right, so the next step, step number 3, is to determine the zero state response, okay, which is given by this equation, the convolution of the external input and the impulse response. So we are given external input is u of t, so convolution with our impulse response, which is 5e minus 3 over 2 t ut. Now this one, the multiplier here is 1, multiplier here is 5, so we can write 5 times 1, this is 5 ut convolution with e minus 3 over 2t ut. Okay, so next we have to refer to the convolution table. Okay, for example, given here. Now we have here u of t and e lambda t ut. Okay, so if we look at the table, we have this similar to what we have, right? So because of this this property of the convolution integral, okay, it doesn't matter if this ut is x2 or this ut is x1, okay, you will get the same result. Okay, so in this case we have ut first and then lambda t second, but the result will be the same. We can still use this result, which is 1 minus e lambda t over minus lambda ut. So we have here 5 1 minus e lambda minus 2 over 3 over 2t divided by minus 3 over 2 minus lambda u of t. So we have here 10 over 3 1 minus e minus 3 over 2t u of t. Right, so this is the zero state response. So next step is to find the total response, okay, which is the sum of the zero input response and the zero state response. Y of t, we have the zero input response, okay, we have determined or calculated before, which is 3e minus 3 over 2t plus this one in the previous step, so 10 over 3 1 minus e minus 3 over 2t ut. So this is the total response of the linear differential equation, the linear differential system. Okay, so thank you for watching this video. I hope this will help you in answering the quiz and also the assignment given to you. Thank you.